Good morning. This is Emerson with Atago in Japan. Today we're going to have a very quick webinar about liquid eggs. It's going to be based mostly on how to use our viscometer in the industry of liquid eggs. But at the end, we're also going to cover a couple of other instruments that are very popular for this industry, especially our inlines. So liquid eggs are a up and coming industry. It's been for a while, but it's getting more and more popular with restaurants, with hotels, especially with schools, because storing and shipping and moving in general eggs is a little bit more delicate than shipping and handling or moving and handling carton boxes of liquid eggs. Also for for restaurants or like schools where you have a lot of, you're cooking a lot, it's more for storage, is better for storage, more efficient for storage if you have liquid eggs instead of your regular eggs. So there are a few countries that are very popular for liquid eggs. Netherlands, the US, France, and India is also coming up with this. The liquid egg industry in India is also coming up. So liquid eggs are, sorry, can I jump myself? Liquid eggs, also referred to as LEP, liquid eggs products, can be divided into mostly three different types. LWE is for liquid whole egg, which can be just liquid whole egg or can be salted liquid whole egg. So there are two products, with salt and without salt. LEY, which is liquid egg yolk, which is only the yolk, or mostly only the yolk, and LEW, which is liquid egg whites. Okay, so the liquid whole eggs basically is the whole egg. It's the whites and the yolk in one. It's all mixed. Liquid egg yolk is only the yolk, so that tends to have a higher viscosity. And liquid egg white is just the white, which is the lowest viscosity of them all. Okay. Depending on your product, viscosity will vary depending if it's which one of these. Yolk will have the highest viscosity, egg whites will have the lowest, and whole eggs will have that middle range viscosity. If it's salted, then it also increases viscosity, and also if it's depending on the diet of the chicken, depending on the different things that you're putting in the liquid egg, the viscosity will change. Not only what's in the egg or what part of the egg can change viscosity or has a different viscosity, but also the temperature that you're reading. There's different standards online as to what temperature you should read liquid eggs. The most two popular ones are at 5 Celsius and 15 Celsius. I've seen a few people do it at room temperature at 20 Celsius, but not much. The standard seems to be around either 15 or 5, depending on what you're measuring. So viscosity does change with temperature. So know that if you're reading a liquid egg, the same liquid egg at different temperatures, you're going to get a different viscosity. So make sure you're reading at the same temperature. We're gonna look into temperature later on, but because temperature is important when reading viscosity, one of our accessories, the temperature controller, is very popular for this industry. Later we're going to look into that. Also, the additives used, like I mentioned before, if you use different additives, then it can change the viscosity of your egg, of your liquid egg product. Dilution. Some people are diluting their eggs with water, especially maybe like the yolks, to get it to a certain consistency or certain viscosity, to meet standards. Because, for example, if you have just the raw yolk, it might be around 800, 1000 CP. but there's some certain standards, and some people want to get it to a lower CP so that they can freeze it. Then they're either diluting it in water, or they're using the albumin, which is the little bit of the egg white, to dilute the yolk. Like I mentioned before, the egg white is the lowest viscosity and the yolk is the highest viscosity. So if you want to bring down the viscosity of your egg yolk, then you want to dilute it with either water, or more popular is the egg white. Okay. All right. A second. Guess where were we? And also, where in the process, the viscosity will change in different points of the process, even though you're dealing with the same egg. And we're going to talk more about that here. So if you have a fresh egg, you have a fresh cracked egg, and you just separated the yolk from the whites, or maybe you mix the yolk and the whites together, but it's fresh. You either have very fresh egg whites, very fresh egg yolks, or very fresh whole eggs that you just liquefied. You're about to start the process, either by separation or pasteurizing or heating, or different ways that you're going to process your egg. That process, the whole process that the egg goes through, from being a fresh egg to a liquid egg, each step of that process breaks down the molecules in the liquid egg and makes your egg a little less viscous. So it's normal for you to have a high viscosity in the beginning of your process, and by the time you get it ready to pack in the carton, it's lower viscosity, because every step, every movement is breaking down the molecules. If you're pasteurizing it, then it's breaking down the molecules. If you're separating, it's breaking down the molecules. So as you go processing this liquid egg, then the viscosity will go low. Will be lower. Also, after it's packed, there's two types of packing for liquid eggs. Is either packing it as a frozen product or packing it as a cold product. So something you have to keep in mind also is that if your product is frozen, if you have liquid frozen eggs, sorry, the longer it's frozen, especially with water, but the longer it's frozen, the lower the viscosity will be when the consumer thaws it out. So it doesn't apply as much for cold stored liquid eggs, but it does apply mostly, or a lot more, for when the liquid egg is frozen. So time is a factor that changes the viscosity of the egg while it's frozen. So keep that in mind. Okay. So we have a few models that are applicable for this. If you're dealing with liquid egg yolks only, then the base viscometer, the Visco, is an option for you, as you can see on the image. But this option does not include temperature control. So you will have to find a way to control temperature. Either put the egg in the beaker, and then the beaker in a water bath, and then take it out of the water bath and hurry measure it. Or you can even put the Visco, since the design of the legs, you can put the Visco in the water bath. It's not gonna go, you're not gonna break it, as long as the height, the water doesn't go too high, doesn't get into the instrument, it's just on the legs. You can put the instrument in the water bath. Okay. If you are doing whole eggs, egg yolks, and egg whites, then there's two options. The reason this is an option for egg yolks is, remember I said that egg yolks have the higher viscosity, and this instrument, as is, the base instrument, measures up to the viscosity of the egg yolk. But if you're dealing with whole eggs or egg whites, which is a lot lower viscosity than the yolk, then you need adapter. You need a ULA adapter, ultra low viscosity adapter. And we have two options for you. We have the Visco package B, which is this. As you can see, it's a little different than this. It's a lot taller. This is the low viscosity adapter with the low viscosity spindle. It has no temperature control. Or you can go with the Visco. Sorry, that's not package B. I think that's package C. You can go with the Visco with the temperature controller. Maybe I should just change this to Visco. Visco the temperature controller. So the Visco the temperature controller, at least temperature controller complete, has the option for you to read low viscosity on it. So you can read low viscosity, which will be common with the whole eggs and with the egg whites, and you can control temperature. So your temperature is stable, your reading is stable, and you're meeting standards at reading these eggs at the desired temperature of either 5 or 15, whichever you're working with. Okay, the benefits of Otago viscometers is that it's small volume. So if you're used to this, if you're used to other types of viscometers, more than likely you'll be using 500 milliliters of that sample to measure viscosity. The Otago Visco uses either 16 or 100 milliliters to measure. So you're going to be using a lot less product to measure the same viscosity you've been measuring. Also, as you can see, maybe you can't see from here, but you're going to see in the video, they're going to show you it's a very compact design. So it takes up a lot less real estate on your table than other instruments you might have in there. And it's also portable. It's easy to use and affordable. It's one of the most affordable temperature controller options in the market for viscometers. Okay, so let me start off with the video. We have a video that we're gonna show this model measuring the egg yolk, this model measuring, don't remember, it's either the whole egg or the egg white, and then this model measuring either the whole egg or the egg white, whichever this one did not measure. Okay, so let's start that video. Liquid egg. So this is from a Japanese brand. They have French wording, but it is a Japanese brand of liquid egg. This one is the egg yolk. As you can see, it's very thick, very viscous. So in the video I had already chosen the spindle to use. So you're gonna fill it up to the guide. We're gonna use a A1 spindle and a large beaker. So the option, you have two different options for beakers. We're gonna use the large one. As you can see, Visco is very small. Okay, make sure that the line, there's 3 lines here, as you can see from the left image. There's 3 lines. Make sure your liquid egg comes up to the, whichever sample you're measuring. Make sure it comes up to the second line. Okay. See, the Visco is very small. Look at my hand. Fits. What I'm doing right now is I'm leveling the instrument. Your instrument should always be leveled before you're taking readings. You can also see the temperature is 19.3 Celsius. I'm not controlling the temperature. It's just what the temperature is. By the way, this product was frozen. So all of the 3 cartons that I'm going to measure was frozen. So I needed to tie it up before measuring. And this one read 150 CP. Okay, now I'm measuring whole egg. And this is with the temperature controller. Yep. Now I'm filling up to the line guide that's there, putting it in the temperature controller, and then I'm going to set up the stand so I can put in the long beaker, which is the low viscosity beaker, the ULA beaker. And I cover it so that I can protect more the temperature from the ambient temperature. Then I'm going to set up the target temperature, which is 15. As you can see from the video, I didn't set it up to 15. I set it up to 13.9 so that my instrument, Visco, displays 15 because I want to measure it at 15. So the controller to the left of the instrument is only controlling the temperature. You need to pay attention to what the viscometer's temperature is and use the controller just to bring it up or down to the desired temperature. Okay. Here I'm just readjusting it so it goes down a little to 15.0. Waiting a little to get to target to 15.0. Then I'm removing the temperature sensor and start reading. Okay, and at this temperature, at 15, it was 21 CP or MPAs, millipascal. And the next product is egg whites. So this time I'm measuring with the ULA adapter that has no temperature control. I'm putting in about 60 milliliters of the product. You can see it's egg white is the least viscous of them all. Putting in the beaker in the stand, then lowering the spindle. Okay, can't barely see, but it's covered. You know, it gets to that level where it has to cover the whole spindle. And that's the setting. I'm using UL spindle and 250 RPM. Viscosity is about 4. And that is the video. Let's go back to the PowerPoint. Those are the 3 options for you. I would recommend this one because it has temperature control, so you can have a more accurate and repeatable result. And as I mentioned before, I want to go over some of the other instruments that are popular for this industry. CM100 Alpha, especially Varivent CM100 Alpha, is very popular for measuring liquid eggs in tanks, but more specifically or more popular in the pipes. So as the liquid egg is being transferred and is going through the pipes, this inline refractometer is measuring the concentration. So we're not talking about viscosity now, we're talking about Brix or concentration. And also, the PRM is popular, especially if you're doing powdered liquid eggs. Then you need to get the egg. You need liquid, sorry, not powdered liquid eggs, just powdered egg, or protein. If you're isolating protein from the egg and you're doing different powders from the egg, then you're using an inline. Basically, you're cracking open the eggs, you're making it into a liquid, and then you're passing it through evaporators to make it more concentrate, and then you're putting it into a, what's it called, a blow type evaporator. Sorry, I don't recall the name right now. But basically, it blows air into these little droplets of concentrated liquid egg, and it evaporates. It finishes the evaporation process, and you end up with powder. So if you're doing that, the inlines are very popular. Also, in the beginning, I mentioned that we had some liquid egg products that had salt comes already salted. That's why our salt meter, PAL salt, is very popular, and our PAL Brix salt, which measures Brix and salt, is also popular. So these are the instruments popular. If you have any questions, please contact us, or you can email us at, give me a second, overseas@atago.net. Thank you very much.